Today we are talking about naming some organic molecules that we call alkanes. Everybody should know at this time that alkanes are saturated hydrocarbons, meaning that they have all carbon, hydrogen, and carbon-carbon bonds, the maximum number of hydrogens that we can get on there. We know that they're basically the building blocks of life at this point, and there's lots of different uses for the alkanes. And what we want to focus on now is using the prefixes that we have over here to go ahead and try and name some of these molecules. So let's take a look at our first example. Now, whenever we go to name an alkane, the first thing we want to do is find what's known as the parent alkane. The parent alkane is the longest continuous chain of carbons. So in this one, it's pretty obvious that the longest continuous chain would be that one right there. So what we want to do is count the number of hydrogens and the number of carbons that is in this parent. So we have 1, 2, 3, 4, 5. So we go back to our prefixes and we see that the prefix for 5 is pent. So this is going to be pent, describing the 5 carbons in our parent, the longest continuous chain. And because it's an alkane, alkanes will always have the suffix ane. So this is a pentane molecule. Now our pentane molecule is a little different because we have what's known as a substituent. We have 2 substituents attached to the parent alkane. I often visualize the parent alkane as the backbone, with the substituents being the arms and the legs hanging off of it. Now, if the parent is an ane substituents, these are carbon substituents which have a special name. They are called alkyl groups. Pardon me on that there. Let's go. Alkyl groups, and alkyl groups end in YL. So now when we look at these substituents, if we look back at our prefixes, meth means 1 carbon. So each of these has 1, so this would be a methyl. Each would be a methyl group. And so what we want to do is tell everybody where the location of those methyl groups are. So we want to number our carbon chain so that the methyl groups get the lowest numbers possible. So 1, 2, 3, 4, and 5. So my methyl groups are located on the 2nd carbon and the 3rd carbon, so I'll indicate that. 2, 3, and then I put a hyphen, and there are 2 methyls, so I'm going to call it a dimethyl. 2,3-dimethyl pentane. So we can see that there's no spaces here. I use commas to separate the numbers and hyphens to separate the letters, the numbers in the letters. Let's try another example. So here we're looking for our parent alkane. It might be in most people's inclination to say that this is the parent alkane. However, when you count the carbons here, we have 1, 2, 3, 4, 5, 6. We could do better than that. So we're going to go ahead and remove that and see that I can highlight there. So sometimes these things aren't straight. They're like spaghetti noodles. They kind of curve and twist and move around. So now we can see 1, 2, 3, 4, 5, 6, 7 is going to be my longest continuous chain. So we look back and the prefix for 7 is hept. So this will be hept. They're all single bonds. So it's an alkane, so it's a heptane. We want to number it so that all of the substituents, so let's look for our substituents now. There would be something hanging off the backbone, there, and there. So all my substituents get the lowest numbers possible. So we're going to say 1, 2, 3, 4, 5, 6, 7. So now my methyls are at, I have a methyl at 3, and I have 2 methyls at 4. So this is going to be 3, 4, 4. Everything gets a number, even if it's a repeated number, and there's 3 of them, so it's going to be trimethylheptane. 3, 4, 4, trimethylheptane. Take a look at another example here. Now this one's a little bit different. Now we see that this one is in a ring. Anytime we have something in a ring, that is going to be our parent. So meth, eth, prop, bute for my prefix here. Bute is 4. They're all single bonds in the parent, so it's butane. And then I need to look for my substituents. So here's my substituents. Now this was a single carbon like we've been seeing, so that will be a methyl. But now this one has 2 carbons. The prefix for 2 was eth, and it's a substituent, so it would be an ethyl. I want a number so they get the lowest numbers possible. We also tend to put our groups in alphabetical order, so I'll give this the 1, 2, 3, and 4. So we're looking at 2 locations here. So now this is going to be slightly different. No dis or tris here. These are different groups. So this is going to be a 1 ethyl, 3 methyl. Now you'll notice I left a little bit of space there. It's going to be tough to squeeze it in, but if somebody just looked at this name, they would see butane and think that it was a straight chain. But it's not a straight chain, it's a circle. And so the prefix we use for a circle is cyclo. So this will be C-Y-C-L-O. Barely got it squeezed in there. So this is 1 ethyl, 3 methyl, cyclobutane. That one was a little bit tougher. The last thing we want to do is just try and work backwards. I think that this is a little bit easier. Just start breaking it down. Start with the parent. So the parent is hept. So we look back, and the prefix for hept is 7. So we're going to draw 1, 2, 3, 4, 5, 6, 7 carbons. These carbons are going to be bound together here. And then we are going to include some substituents hanging off of here. So I have a 4 ethyl and 2 methyls. So 1, 2, 3, 4. So I'm going to go ahead and hang an ethyl off of here. And then at 2, there's going to be a methyl. And at 3, there's going to be a methyl. So this is the general shape of my structure here. Now, I put both my methyls up. I could have put them down. I put my ethyl down. I could have put it up. It doesn't really matter as long as they're at the right location. Remember, these are like spaghetti noodles. They twist and curve. The last thing we need to do is put in our hydrogens. Now, in organic chemistry, because there's always so many hydrogens, we don't always show bonds to the hydrogens, but you could if you want. For example, we know carbon has 4 valence electrons. It always wants 4 bonds, so those additional 3 bonds have to be to hydrogens. And we could show them all like this if we want. So this carbon here needs 2 more hydrogens. But most organic chemists, and students for that matter, get lazy and we just show them like this. So I'm going to put 2 more here, 2 more here, 3. Now this one has 1, 2, 3, so we only need 1 more to make 4. That's going to be 3, that's going to be 1, 1, 3, and finally 3. And so that should do it. Hopefully you guys can watch this through a couple of times. Make sure you understand to name the parent first. Make sure it's the longest continuous chain. Identify those substituents, and everything should come together after that.